All right, so let's begin with this video. I'm going to discuss a couple of things, especially the theory of building an AI system, right? We'll start from the very basics, the entire discipline of the process that we should follow. Its theory, as far as application is concerned, there are a lot of ways in which people like to approach the entire process of building an AI system or a product or a solution, whatever you want to call it. But it helps to have a framework to have a reference point to start from, and that's something we're going to discuss in this video. In subsequent videos, I'm going to go on to take an example of a data set and explore some models like linear regression, and then some classifier models that are very simple and very basic as well, like logistic regression or decision tree classifiers, for example. So let's just start with the basics for now. As far as some prerequisites are concerned, if you want to follow along, I'll show wherever possible in all the videos on my channel. Wherever I'm using data, I'll try my best to show the origin or the source of where I downloaded the data. Anyway, it's going to be less of tutoring and teaching and more of, work it out along with me kind of approach. Because I'm also just getting into AI, deep learning, machine learning, right from the basics, because I believe that basics and building a good foundation are important. Anyway, some prerequisites are, I'm going to rely on Microsoft Excel and later on Python as well for all of the stuff that I'm going to explore. Excel Miner toolpack is something useful to install in Microsoft Excel because some basic modeling is going to be done on Excel, and it's just much more handy and easy to use Excel Miner to do that. On my channel, I want to explore applied data science, which translates to machine learning, deep learning, etc., and not go too deep into the mathematics of stuff. So let's not worry about that for now, right? Maybe I'll upload some other videos or shorts to deal with all of those concepts. So if we talk about building an AI system, there is a circular framework that is quite popular, and I have made my own version of it, which is fairly detailed. I think I have added a lot more steps over here based on what I have observed from my experience of leading teams that build machine learning products. So we start right from the top, which is the business opportunity, or you look for the very human problem to solve, right? Something that you want to be done better, faster, or cheaper, right? So, if I have to take an analogy, if I say, I am a person who wants to get from point A to point B, right? So, there are several ways to do it in that case. I mean, without asking any further questions about this problem statement, I could straight up say that I could walk from point A to point B, I could take a bicycle, or a motorcycle or a car, right? Or I could use public transport like a bus. Um, Now, the choice of the solution depends on various other factors. So, therefore, I need to go and ask more questions about what is it about getting from point A to point B, right? What is my objective? Why am I going to point B? And is there a need to return, right? What are the various I mean, is there more information about these points themselves, right? Point A and B. So I need to ask these questions. So why am I going there? Okay, I might say that I'm going to meet some friends, and for coffee or and a little bit of chit chat. I would say that I need to go buy some groceries, or I need to get my okay, I need to get this very large television repaired, right? So I need to take it to the repair shop, or there could be some other purpose. So the purpose matters, right? That's the question that I'd ask. So then, depending on the purpose, if I'm just going to meet some friends, then I could choose any of the modes of transport I stated. Or, if it's for a very specific purpose, like repairing a 55-inch TV, now I can't carry that on a bicycle or on a motorcycle. I have to take the car, right? Alternatively, if I have help with one more, friend or family member who can help me carry it, I could use public transport as well. And so therefore that helps me narrow down the solution, which is the mode of transport that I need to take. How far is point B from point A? If it's just less than maybe 200 meters and I don't have a lot of heavy stuff to carry, then I could just walk the route. If it is about 4 or 5 kilometers away, then yeah, walking is not an option. I could maybe opt for some other mode of transport, right? So the thing is that, asking questions about the problem to be solved really helps you identify and zero down on the solution approach. Enough about the analogy. I think if we just focus on a technology problem now, if it's about, some problem like, okay, I am a lawyer or I am an analyst for some accounting firm, let's say. There are a lot of documents that I need to go through, and it always takes me a lot of time. Can it be done faster? So, if that's the kind of problem, then, it's about saving time, right? There are a lot of questions you could ask, but, already you could think that maybe if there could be some kind of a system which is able to categorize documents and documentation if they're in digital format, then that is something that could help the person, the analyst, or the person in law. It could be a paralegal, for example. It could help them sort through the documents faster or in a more organized manner, right? There could be categorization like alphabetical categorization, or there could be some other kind of categorization, as in by the type of problem or the domain. Yeah, if it's about housing issues, or if it's about commercials, uh, commercial properties, if it's actually a corporate law case, something like that. So these are all rule based solutions. Yeah, maybe it can help this person become maybe 15% more efficient in their work. Uh, and then, you have to look at available technologies, right? So if you have technologies today, 2025, like natural language processing, right? You have generative adversarial networks based solutions like ChatGPT. You have a solution from Google like a Notebook LLM, for example. You know, uh, these can actually help summarize so many documents together much, much faster, right? Just try out Notebook LLM, for example. Then, using such solutions, I could make this person, who is a paralegal or maybe an accounting analyst or an accountant, they can actually sort through so many documents at 3 or 4 times the speed, right? It's just much faster to find specific text or sections that they're looking for. Yeah. In fact, in my previous roles, I've worked for many years in telecommunications. So anytime there is a problem to be identified or a solution to be devised, everything required reading through very extensive the GSMA documentation. Sometimes it could be like to answer an RFP or a client requirement. I'd have to sometimes go through 10 to 15 such documents, each more than 100 pages long, just to address one little bit of solutions, right? One little solution or just 2 or 3 questions, let's say in an RFP response. I used generative AI to quickly go through these documents. Normally, for so much documentation, it would take me maybe a week to really study through everything. But if I use AI to help me, Of course, I wouldn't totally depend on it. It would just be a starting point to point me to exactly what sections in each document are relevant or not, or is the entire document irrelevant, right? There's a lot of prompting, a lot of questions that ask, and then I wouldn't say it made me 5 times faster, but it helped me cut down more than half my time, right? So instead of 1 week, I would be able to attend to the problem at hand, answer the question within 2 days, right? Uh, Cross checking and cross verifying everything that LLM would tell me. So if you have evaluated at least 2 or 3 solutions, and then you go to the second point over here, quantify the expected outcomes, right? So if I'm able to make something faster by 15% with one solution versus faster by 50% with another, and then a third solution makes it 200% faster, then of course I'd go for the third solution by that metric. Yeah, so it's important to identify the correct business opportunity or the problem to solve. It's important to ask the right questions. It's important to then have a collection of as many choices as possible. Solutioning is supposed to be as broad as possible, and then if you know exactly what you want to achieve, quantify it, and then evaluate each solution against the number that is quantified, right? The objective that you want to achieve. Okay, so now this model that we see over here, it assumes that we are looking at a problem where we have identified that an AI solution is the best way to go, right? So then maybe, let's say we'll use a classical machine learning model, or do we need to go for deep learning or, generative AI? That is something that depends on the objective and the data that we have. Okay, anything that's AI requires data. So that is why we have all of these steps: data acquisition, data inspection, data cleaning and preparation, all of that. Because let's face it, in real life, data is not perfect. Case in point, there was a neural network for image identification in the past that became racist. I will not say more about this. You can definitely look it up on the internet. And Google had to pull it down, right? So this was many years ago, I think in the last decade. So data acquisition and inspection, cleaning, preparation is very important, right? I'll not go into details over here. I wanted to really stress on the first two um, steps in this entire process, right? And then maybe there's some data transformation, maybe there are some values that need some modifications, some additional calculations, concatenation, plus, minus, divide, multiply, something like that. After that, the next, in fact, the last four steps are to do with creating the ML or DL model, refining it, and testing it, and finally deploying it. And all of these processes are, they are quite detailed. There are many ways in which these are dealt with in real life. Uh, what we'll be doing gradually is we'll first see a very, very, student version of machine learning and deep learning modeling and refinement and testing, and and then we'll also see how these could be deployed in subsequent videos. So anyway, the focus that I want to the focus of this video and a couple of other videos later is going to be to look at the basics of building a machine learning model, what it means, getting a good intuition and feel for it, and also a little bit of mathematics that actually justifies what we are looking at, right? How to build a model, how to define it and prepare it. I'll keep revisiting this entire diagram, this framework, as we go through the steps, and we'll see practically for ourselves that how this process is actually implemented and achieved.